Hello, I am here to present the latest updates to the dummy and the HBM positioning tools in Oasys Primer 21.0. This video talks about the circular assemblies and connections in a dummy or a HBM. Oasys Primer can already perform positioning of these circular assemblies using the drag tool. From V21.0, the rotate tools method can also be used to position these circular assemblies. As you know, the Oasys Primer can be used to position the dummies or human body models into desired position and orientation. This positioning exercise in Oasys Primer is done prior to performing the positioning analysis of these dummies or HBMs in LS-DYNA. The positioning of these dummies or HBMs is achieved using Oasys Primer positioning tree data. In the positioning tree data, all the logically related parts of a dummy or HBM model are grouped together in what we call as assemblies. A root assembly is chosen as a parent. This is generally the pelvis assembly. Then rest of the assemblies are connected using a strict hierarchical parent-child relationships. Like if pelvis is a root assembly, then thorax and leg assemblies are going to be a child of pelvis, and the head and the arms assemblies are going to be a child of the thorax. And likewise, all the limbs of the dummy or HBM will be connected to each other. This means that a child assembly can be connected to just a single parent assembly. The permissible relative motions between these assemblies can be set using the degrees of freedom or DOF codes along XYZ axis. Once these relevant assemblies and connections are created, the assemblies of the dummy or the HBM construct would move relative to each other as if these are rigid bodies connected via some mechanism for their relative movements for the purpose of positioning. These positioning tree files, when loaded into Oasys Primer, would help users achieve realistic positions for the dummies or HBMs. In a previous version of Oasys Primer, we had relaxed the rules for the dummies or HBM constructs to allow a child assembly to be connected with more than one parent assembly. In the image shown here, a parent has two children C1 and C2, which is just a normal dummy or HBM construct. However, a grandchild G has two parents C1 and C2. This means all the C1, C2, and G must be treated as a composite rigid body that rotates about node on parent P and must not be allowed to move independently. Now, if an assembly is connected to two or more parents, they must set the degrees of freedom or DOF codes to be pin for a single point connection or a line or hinge for a two node connection. This is useful in setting up more realistic connections in assemblies constructs like movement of clavicle assemblies connected to the shoulders and the arms while also being attached to the rib cage or the thorax assembly, or lower arm rotations with radius and ulna assemblies both connected to the hand, or even better control over movement of spine assemblies. This is the thumbs V7 male occupant human body model loaded with Oasys positioning data. The traditional parent-child hierarchy in a positioning tree would have an upper arm as a parent assembly, lower arm as a child, and hand as a grandchild. Here the arm movement is restricted to rotation at the elbow and flapping of the hands. To rotate the palm, circular assembly connections are created in the positioning tree. Now our lower arm assembly is split into ulna and radius assemblies. Both these assemblies have upper arm as a parent assembly and hand as a child assembly. From Primer 21.0, it is possible to use the rotate angles positioning method to position such circular assemblies. The assembly names in the positioning panel will have subscripts in red color to denote the following. R is the root assembly, E is an assembly that is part of circular connections, and M has multiple parent assemblies. The angle values of all the assemblies with circular connections are displayed with a gray background. The rotation of the assemblies can be done by inputting the angle of rotation for the assembly or by using the mouse drag to rotate the assembly into a desired position. Thank you.